All right then, so quick disclaimer slide. I'm sure you're going to see this through almost every session. Hope it was long enough for you guys to see. So the agenda for today, quickly going to touch upon our view of what cloud computing is about and specifically what the private cloud means to us. More specifically, what is vCenter Server's role in enabling you to manage a private cloud infrastructure? I'm going to touch upon vCenter Server 4.1 that was just released, some of the high level or the highlights of some of the improvements and new features that were introduced, and then kind of go into the meat of this discussion, which is around the best practices themselves. And finally, Q&A. If it seems like we are rushing, we are, because of the time constraints I mentioned, but as I said, we'll catch up either in detail after the general session ends. So, what is cloud computing, right? I'm sure you guys have heard many different definitions of what cloud computing is. At VMware, we believe that cloud computing is essentially an approach to computing that leverages efficient pooling of your virtual infrastructure resources and consumed as a service on an on-demand and a self-managed basis. So what does that mean? So our goal with cloud computing is essentially to deliver IT as a service, or rather enable you to deliver IT as a service to your end users, whether they are business users, whether they are application owners, and pretty much on the same levels as you would find services being available with utility-based services like your phone, like your electricity. So essentially the same characteristics that you would typically associate today. So for example, phone services, you use them when you need them, you pay for what you use, right? And you don't really have to be bothered in terms of how is that infrastructure providing those services to you. So similarly, cloud computing is about the same. You can request services whenever you need them. You can specify the service levels for the services you consume, and then you pay for what you use, right? Ultimately, it's really about end user centricity, right? So how do you get to this cloud computing model, or how do you get to delivering IT as a service? We believe there are three ways of getting there, right? The most straightforward way, and again, assuming if you are already doing some sort of virtualization in the data center today, would be to essentially deliver your internal private cloud. This is applicable to most of you, I believe, right? But if you are just getting started with your virtualization journey, another option you could start with going towards cloud computing is leverage a VMware-based or a vSphere-based public cloud, where you can pretty much get started right away. And assuming you have a private cloud instantiated, and if you choose to also consume aspects of the public cloud, since you have this dual environment that pretty much maps each other closely, essentially your private cloud is pretty much similar to your public cloud. There shouldn't really be any difference other than the fact that a private cloud is managed by you, public cloud is managed by some service provider, right? But essentially at the end of the day, it essentially can be managed as a single elastic hybrid cloud that basically enables portability of all of your applications and your data. Now, talking more specifically about the private cloud. So VMware's private cloud model is based on the vision that VMware's private cloud vision is based on the vision that the data center of the future is becoming more of a compute factory, where each of the part pieces, whether it's CPU, whether it's memory, storage, network, you name it, all of these are being virtualized, they're being aggregated, and they're being offered in a standardized form of services that can be easily consumed by the end users. And you can actually specify your quality of service levels, whether it's availability, whether it's security, right? And essentially, as I said, it's all about end user centricity, enabling users to demand and access services whenever they need it without having to be bothered about the underlying infrastructure, right? Now, at the foundation of what really is involved in enabling you to not only deploy but also manage your private cloud is the vCenter server, which forms the private cloud management layer for your infrastructure. And it's based on the guiding principles of automation, scalability, visibility, and extensibility. So what does it mean for vCenter Server to be a private cloud management platform? We believe there are three areas that define or characterize vCenter Server. And we roughly break them down into baseline vSphere management, which is basically about a collection of services that you can use to manage any inventory objects, whether it's VMs, whether it's hosts, your clusters, vApps, or for that matter, even your physical infrastructure, right? In addition, there are core platform services that deliver services such as licensing, the ability to gather, monitor stats, generate events, generate alarms, the ability to query across all of your inventory objects. Also, there's automation, which means that you have the ability to use your CLIs or APIs or write your own scripts to manage your infrastructure in the way you deem as being right. Then obviously there's the UI framework that that's very extensible, that provides you different ways of providing role-based interactions, right? And also there's authentication, authorization to make sure that the right people are accessing the right objects at the right level. And then there's the platform essentials, which is basically how do we make it easier for administrators to easily manage their infrastructure with low overhead, and at the same time allow our partners to integrate with this management model to build out a broad management infrastructure across physical, virtual, you name it, whatever else fits that picture. So one of the things that we recently or rather the major thing that we recently released with vSphere 4.1, or rather as part of vCenter Server 4.1, is that vCenter Server is now a 64-bit application. So that obviously means that you can no longer deploy vCenter Server on a 32-bit platform, and you can only deploy on a 64-bit. Now you may ask why. And the reason we made this change is primarily around delivering greater levels of scalability and performance. So I'll give you an example. So in a 32-bit architecture, one of the things that we have always been gated by is the fact that on a 32-bit Windows OS, which today vCenter Server runs on, we always run into 4 gigabit virtual memory address space limitations. Because of that, we cannot scale vCenter beyond what a 32-bit architecture offers. So since here we are on a mission to deliver cloud management capabilities, when you talk about cloud, you're actually talking about scale. Scale in terms of not just hundreds of thousands, but at some point in time, millions of objects. And there's no way we can scale on a 32-bit architecture. So that was one of the main drivers for going 32-bit. Another advantage of going 32-bit is that it's now able to take advantage of powerful hardware that you are typically deploying today, right? For example, additional memory. vCenter now being able to consume additional memory in excess of the 4 gigabit limitations that we were running into, it actually allows us to now cache frequently accessed data in memory so that we are being more efficient, not just in terms of scale, but also in terms of performance. There are other things that we have improved from a performance perspective, which is we have drastically reduced the vCenter Server startup time. It's up to a factor of 3x reduction at full scale. Given that we talk about scale in numbers of, and actually let me tell you the numbers we are referring to here. A single vCenter instance can now manage up to 15,000 registered VMs. It can manage up to 10,000 powered on VMs, right? The number of concurrent vSphere clients has also drastically increased by 5x. So you can see that across the board, there is a 3x to 5x scaling factor that's been introduced as a result of going 64-bit and the other performance improvements that we have done. The other high-level or highlights of vCenter Server 4.1 is around host profile enhancements, which includes now support for the Cisco Nexus 1000V, the ability to configure your ordering of your PCI cards, and also the ability to configure or change the root password on your ESX host using host profiles. There are some improvements on Update Manager around the ability of being able to recall patches wherein Update Manager can actually send you a notification saying that we have recalled these patches. And what happens at that point is, assuming these patches have been downloaded, you will get an alert in your dashboard saying that these have been recalled. So even if you were to try to attempt to install these, it would block it from being installed. And let's say even if you've gone past that point wherein patches have been rolled out and then you get this notification for saying these patches have been recalled, Update Manager will actually alert you to saying, oh, these hosts have been updated with these recall patches. Now is the time to remediate, right? So these are some of the Update Manager improvements around patch recalls. There is also added support for third-party modules in Update Manager where it can provision, configure, update third-party ESX modules, for example, PowerPath. Right? Converter can now directly import Hyper-V VMs without having to do the traditional P2V. It actually does a virtual-to-virtual conversion. There is now Active Directory integration with, or rather ESX integration with Active Directory, so that if you were in the past manually adding users on your ESX host, you don't have to do that now. You can configure your users in AD and point ESX to it. Also, host profiles and the vSphere Management Assistant are able to leverage this new integration with Active Directory. Last but not least, there's a new feature that's being delivered, which is called the Virtual Serial Port Connector, concentrators rather. What this is basically a non-graphical, low bandwidth, secure remote console for you to use for any of your VMs. And this is pretty similar to what you have in the physical world, wherein if you want to access any of your host serial ports using a concentrator that basically multiplexes host connections over the network, this is somewhat of a virtual offering for that. It's definitely recommended in situations such as remote office, branch office, where you have low bandwidth, high latent networks, and we have always been recommending you guys not to use the remote console because of the amount of bandwidth it sucks. So this is definitely an option for where serial port access could be an alternative. All right, now I'm actually going to move into the meat of the session, as I call it. I've tried to structure this across various aspects of the vCenter management lifecycle. So it covers things around the planning phase, the deployment phase, the operations phase, and what we call is the protection phase. And we'll go through that, starting with planning. So depending on where you are in terms of your journey to cloud computing, planning will always be an important factor to consider, whether you are starting fresh, whether you're transitioning to a new major or minor version, or if you already are settled with an infrastructure that you think is working reasonably well, but you need to consider some factors as you begin to plan and scale towards future needs. So so there are a lot of factors that come into play when you talk about. So we usually get this question from customers. What should be my deployment strategy for Virtual Center? How should I structure it? How many resource pools should I create? How many clusters should I create? How should I group them? What is the expected latency in terms of this operation? And our answer is, it depends, right? Because there is not one secret sauce to what it takes to build a robust management infrastructure, right? There are a number of factors that play in, and I'm going to call out some of these, right? I begin with, workload types, right? Ask yourself, what kind of workloads is this vCenter server going to manage? Is this primarily be dedicated to, let's say, your production server workloads? Is it going to be dedicated primarily for your desktop workloads? Or is it test dev workloads? Whatever is the categorization you have in your environment around it, right? Or do you plan on using the single vCenter server to manage across all kinds of workloads, right? And then the question is, what are your management expectations around each of these workloads? Do you expect the same service levels around each of these? Or do you kind of carve them out wherein you have certain expectations around server workloads and maybe desktop workloads, test their workloads, maybe not, right? And then it becomes even more complicated when you talk about tiering across each of these workloads. So think about some of these considerations as you define your management infrastructure scope. Second, and something that's very key is when you start out building or upgrading your infrastructure, think about the number of objects you are really going to be deploying, which is, how many sites are you going to have, right? If there are multiple sites, are these multiple sites going to be managed by one VC, or do you plan on having individual virtual center servers across each site? then how many VMs come into play, how many hosts come into play. All of these build up in the sense that they affect your actual deployment choice. Consolidation ratios, right? How much are you really looking to target? Are you looking to target a 50:1 ratio, or are you only looking at 4:1 because you want to dedicate large chunks of resources to certain workloads that run on an ESX box? Remote office, branch office considerations, right? Anytime you're going to be deploying ESX hosts at a remote site, think about what is the latencies that you expect in that environment? What is the bandwidth you would realistically get in that environment? Also think about, do you plan on doing any storage replication, or what is the networking story out there, right? Those things need to be considered. And as I said, quality of service around whether, what kind of availability metrics do you anticipate? What is your RTO? What is your RPO? Does it change with regards to certain management applications, right? What are the security levels, and so on and so forth. How many users are going to be accessing this vCenter server concurrently? The more you scale, and vCenter obviously can manage 10,000 powered on VMs. So if you now assume that you're going to run all of your entire infrastructure using a single vCenter server, it will work, right? And we have also adjusted, or we have optimized vCenter to handle a lot more concurrent clients. Because we know that now that the scale has increased, we would expect more administrators to be viewing this single instance, right, or this single console, right? So think about how many users you realistically think will run on that, because it affects overall the vCenter performance as well. And then there are some environmental aspects about, do you run it on virtual? Do you run vCenter server on physical? What kind of databases you're going to be using? What OS types? How frequently are you going to be doing maintenance work on your vCenter server? And whenever you do maintenance, do you have any expectations around downtime or no downtime? This is kind of at a broad level things to consider when you think about deploying your management infrastructure. Going into the deployment phase of things, right? So kind of going to quickly touch upon what are the key components that make up vCenter server. So there are really two things. One is your vCenter service instance, and the vCenter services it's actually more like services, because vCenter has come a long way from being this one monolithic service that does multiple things, right? And in the past has been a reason for single point of failure, right? Now for scale and other reasons and availability reasons, we have actually broken up vCenter server into a number of different distributed services, which all collectively formulate vCenter server. So there is the vCenter services, right, and their configuration. And the second and most important thing is your vCenter database, because anything to do with your infrastructure, your VMs, hosts, configurations, whatnot, everything is being persisted in that database. And as far as the database is concerned, the data that we store is primarily around three things. One is your vCenter inventory, VMs, hosts, blah, 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 right? Alarms and events, which are associated with anything that is triggered as a result of state changes or other thresholds that you have defined for management, right? And the third one, which is probably the most key category within the data, is your performance statistics. Because this performance statistics is what makes up, I would say, up to 90% of your database. So anything to do with these performance statistics is going to positively or negatively impact your performance of your vCenter server. So let me kind of walk you through the performance stats collection, how it kind of works. So today what happens is vCenter server, it obtains real-time statistics from each of the ESX hosts that it manages, right? And every 5 minutes or so, the vCenter server writes these real stats into the vCenter database as historical stats. Now, these historical stats will age over time, but you will get past day, past week, past month, and past year data. And after a year, there are functions within the vCenter database or the vCenter server which will make sure that after a year, if you don't really need it, by default, it will purge that data. So as the historical data ages, vCenter server basically rolls up some of this data and makes it part of a larger granularity. What it does is basically, depending on which collection level you talk about, it actually rolls up this data either every 30 minutes, every 2 hours, or every 24 hours. And this is an ongoing process. And this is actually done by these roll-up stored procedures that run inside the vCenter database as scheduled tasks. And every time these roll-up jobs run, you can actually see that happening when, if you look and monitor your database performance, you will see certain spikes when this thing happens. So what I'm trying to get to is, vCenter database, most critical thing to monitor and plan for, and make sure you have the right controls in place around what kind of performance data you collect, at what granularity you collect, because you can specify level 1, 2, 3, and 4. Level 4 means you have a lot of detailed data. Level 1 means you have kind of a high level summary of the data that you want to store. So it really depends on what your needs are. And then, as I said, there are controls in vCenter where you can actually specify a data retention policy for both your alarms and events. And then there are scripts available which allow you to kind of purge any historical data if you decide that you don't need some data because you have backed it up or you have archived it. It's always a good idea to make use of these calculators, especially if you are starting a brand new vCenter or deploying a brand new vCenter environment. It basically gives you, you basically input how many hosts, how many VMs, how many resource pools that you're likely gonna deploy or manage, and it gives you an idea as to what should your database size should be. All right, so some considerations around the database. vCenter server obviously is a 64-bit app, which means you need a 64-bit DSN now. As far as database support is concerned, it's always good to check the vSphere compatibility matrix because that's where we kind of maintain and update the latest database platforms that have been qualified by VMware. One thing I wanted to point out here is that we have got a lot of questions about, is SQL Server 2008 R2 supported? And I think it released somewhere around in April, I believe. So it has not been qualified by VMware QA, but we can definitely support it if you were to run it in 2005 or 2008 compatibility mode. This is something that we have done. We have worked with a few customers where they have done certain self-certifications, and we know it works. There are no serious issues that we know of. The only caveat here is that if you do deploy in this configuration, and if you run into some issue, you might have to wait until the next update release for us to actually be able to deliver a fix. The vCenter database permissions is very important. It hasn't this best practice actually hasn't changed in the last, I would say, 2 years. Things we require is basically the vCenter database account login needs to have DBO privileges in the case of SQL Server and DBA privileges in the case of Oracle. And why do we require these higher level or escalated privileges on the database? Is because at the time of installation or upgrades, we need to insert certain SQL or Oracle related jobs or stored procedures into the database. As a result of which we need these elevated permissions. But these are only required at the time of install or upgrade. If you decide that this violates maybe your database admin's security policy, then after the installation or upgrade is done, these can be revoked. When I say these, I mean the DBO and DBA permissions on the MSDB, not the VCDB. The VCDB, you still need these permissions. Here are certain best practices in terms of what our field has observed, specifically around SQL Server. There's a lot of information in there. I'm actually going to skip the details for the sake of time. But essentially, the key things I'll just point out to you as it stands, which is, separate out your database, separate out your transaction logs and the temp database on separate physical drives as much as possible. If it's not possible to have them separate, or at least have them on 3 separate drives, at least make sure that the transaction logs and the temp DB are on the same drive, and the database has its dedicated drive. There are these built-in characteristics of SQL Server, such as parallel processing, which is enabled by default, as well as SQL has this built-in cost optimizer that basically optimizes the queries based on access patterns. So from a performance perspective, those two are definitely, we want to make sure those are running and have not been disabled. The recovery model, setting it to full, is actually a best practice for pretty much any database you run in production, whether it's VC or not, right? So just one consideration. As I said earlier, from a performance stats collection perspective, try and keep your stat levels at 1 or 2 unless you really need to gather detailed performance data. And if you choose to do so, then you can configure stats level 3 for past day and past week. But for the more historical data sets, you want to keep them at stats level 1, since they're anyway going to get rolled up into averages. This is another thing that we get asked a lot: should I run VC in a VM or a physical server? And our answer to this is there is really not much of a difference in terms of performance or scale, whichever form factor you choose. But there are obvious benefits of what you stand to gain if your VC was to run in a VM. Right? You free up a dedicated server for running maybe additional workloads. You have the ability, you can maintain service levels for your vCenter server because you have made it part of a DRS cluster, and it makes sure you always get the optimal resources that you specified. Right? You get high availability via VMware HA. Right? You can do backups using snapshots. So there are a lot of positives that can come out of running vCenter server in a VM. But otherwise, if you don't care about any of these, and I would be surprised why you wouldn't, but it's pretty much on par between physical and virtual. And here are some system recommendations based on the size of inventory you're going to manage, because it's very important for you to start out right as opposed to try and fix a broken plan, right? So it kind of goes back to the things that I pointed out earlier. Figure out what your management scope is, and then look at some of these specifics to identify how you deploy these. So in VC 4.0, we actually introduced a service. As I said, we have been breaking out VC into different services. So one of the services that we introduced was a web management service. What it basically does is enables, it's basically the backend is Tomcat, right? Enables multiple web services to be delivered and via a single vCenter server instance, right? You could actually break them up across different services as well. But one of the key limitations that we ran into with especially the 32-bit architecture is that this application, depending on how many apps are instantiated using this, the memory requirements are anywhere from 512 MB to up to 4 gigs. And with a Windows 32-bit architecture, the heap memory size is pretty much gated at 1.6 gigs. So I don't know if anyone has run into these issues, but we have seen a lot of support requests come in that says, hey, my performance monitoring UI is very slow, and this is one of the reasons. You can tweak it to some extent, but as I said, 1.6 is where it caps off. So with the new architecture, given that we are going to 64-bit, we are able to take advantage of the more powerful memory you have on these systems. So at install time, you can actually configure, depending on how many host VMs you're going to manage, you can specify what's the memory allocation for this. And you can do this after installation as well. There's an option within the vCenter UI. I'm actually going to skip this slide. There are a lot of specifics in here. This is primarily around how do you, if you ever choose to migrate between SQL and Oracle once you have deployed your VC, how do you go about doing it? There are certain white papers available as well, but there are certain considerations to think about as well, because it's not as straightforward wherein you use Oracle's migration tool and the migration happens clean. It's not so much. There are some considerations to be thought about. All right, upgrades, very important to know. As I said, we're moving from a 32-bit architecture to a 64-bit architecture. And if you were already running VC on a 64-bit OS, this upgrade process should be pretty straightforward because it's an in-place upgrade. But if you were running it on a 32-bit OS, then you would basically need to use our migration tool, which basically does a backup of the VC configuration. You deploy a new instance of VC 4.1, and basically you can import this configuration into VC. The best scenario is if your database is remote, right? If it's SQL, Oracle running somewhere external, you don't have to touch that database. As part of the VC 4.1 installation, it's gonna take care of that. But if you were, for whatever reason, running, let's say SQL or Oracle locally on the vCenter server box, and if it was 32-bit, there might be certain additional steps to go through. Always make sure that you back up your database before you do any upgrades, right? Also, there's a tool that's available, that's a pre-upgrade checker tool, which actually goes through your existing vCenter inventory and makes sure that there are no ESX host configuration or other networking issues that may prevent a vCenter agent to be deployed on the ESX host. So it's more of a pre-upgrade check around that. And again, if you think that your database is fairly large and it will take a really long time for you to upgrade, then think about, is there any data you can purge, right? Make use of the database purging scripts. There is also an option in VC 4.1 as part of the upgrade process wherein you can choose whether to do an automatic installation of the vCenter agent or a manual one. The automatic option, if you select that, it basically what it does is when you do a vCenter upgrade, it not only upgrades the vCenter server, the database, but it also upgrades the agent on the ESX host. Now, if you have a very large inventory, then the time it takes for it to go and upgrade these agents on these hosts might be considerably large. So if you choose the manual option, it will upgrade your VC instance, it will upgrade your database, it will not touch any of your ESX hosts. But the downside of that is when VC comes up again, all of these hosts will show as disconnected. Nothing to worry about, the host is still running, it's just that VC is not connected. So all you need to do is right-click, connect, and at that point it will go and deploy those agents. The good thing is that you can stagger your vCenter upgrades using the manual method. As I said, it depends on what kind of environment you're running with. This is basically kind of a screenshot of the data migration tools and kind of the settings it backs up and restores as part of the upgrade process. Link mode. How many of you here are running vCenter servers in link mode? Okay, so some of you. Okay, all right. So link mode is essentially the ability for the group of vCenter servers to appear as a single, or rather, let me put it this way. If you have multiple vCenter servers in your environment and you want a single pane of glass for monitoring across your entire inventory spread across these multiple vCenter servers, link mode is what will get you there. So it's not just a single pane of glass, but also you can use the same user roles, their relative permissions, basically all credentials can be entered at one single point, and depending on your privileges, your permissions, you will have access to different parts of your global infrastructure. Today it supports up to 10 vCenter nodes. Best practices around this is to make sure that all of these hosts, they are configured correctly for DNS, their host names and their fully qualified domain names and their NetBIOS names match, because if this is not set correctly, then you might see certain issues around query results, the search results not returning the right information or timing out or certain errors. So very important that DNS be configured, network time synchronization also be in play across all of these instances so that the drift is no longer than 5 minutes. All right, this is another slide I'm going to skip, but this is very important for you to refer to. What this talks about is that many of our customers started out with a single vCenter server, right, pre-VC 4.0. They started to scale. They realized they had a lot of inventory in there, and now they want to move to VC 4.0 and later, right? But now they want to take advantage of the link mode capabilities, right? You want to break up your environment, either for scale reasons, either for organizational reasons, right? The most common use case we get is that, hey, I want to split my VC between a inventory that's desktop, which will be served by its own VC, and then there's another VC that manages only server workloads. So 10 steps to go through in order to get to that. This is, again, something that we have done in the field using help from our PSO org. This is known to work successfully. Our QA hasn't tested it, but we'll definitely support this if you were to go this route. All right. Another favorite topic, mine as well as, a lot of customers talk about this. Very relevant for sites that, very relevant for customers who have a large number of remote offices or branch offices. We call this obviously the robo scenario. So in the past, we have had questions around, or rather the single most important question was, if I have n number of remote sites, right, how do I manage across all of these? If I have more than 10 vCenter servers, or rather if I have more than 10 sites, I have 40 or I have 50, right? Link mode will only give me 10. How do I get beyond that, right? And at that point, their question is, will a single VC at each site be an option for addressing this? Or can I actually get to a point wherein I have a single VC or maybe 4 or 5 VCs, and then each of these VCs manage these hosts remote, sitting remote. And these remote sites may have low bandwidth, high latencies. What is the performance impact associated with this topology that I should plan for? So the answer to this, and especially based on changes that we made in 4.1, is that you do not require a VC at each local site. It's recommended, but again, if you go into a number of scales, like greater than 10 or greater than 15 sites, then it's definitely, you can go with a single VC managing multiple sites route. The improvements that we have done is that, first of all, the operational time associated with the management tasks that are run across these highly latent, low bandwidth networks is that we have been able to shrink down the total operational time from a factor of 1.5x to 4.5x. The other thing to keep in mind is that it's not so much about the bandwidth between your VC server and your ESX host. It's really the latency which is in the critical path of the management impact associated with this. So in order to address this, what we have actually done is we are now compressing all data that flows between ESX hosts and vCenter server. Not only that, we have also reduced the number of hostings, which is basically ESX host saying something has changed on my end and I want to sync up these changes with you. So we have kind of, I would say, staggered them to a much lower number so that whenever there's an update, a larger portion of an update is sent to the VC server, but again, it's compressed. So the cost is very low. Secondly, performance statistics. Prior to 4.1, they used to flow over UDP. So there has been possibility of you losing some performance metrics. But now we have shifted to TCP, so you wouldn't lose any performance metrics going forward. The summary, so we actually did a study around this. There was a team of engineers and TSO folks who actually did this study around satellite links and high latency, low bandwidth links. And they figured out that in addition to all of these findings that I talked to you about, in most cases, most vCenter operations will work fine even over a 64 kbps link, right? So a lot of good things on this side, or this side, but there are certain considerations to think about. Any vCenter server operation that requires a large payload, when I say a large payload, I mean something, if you're sending patches over the wire, or if you're adding a host, because when you add a host or if you are doing a vCenter upgrade, a vCenter agent is pushed out over to the host, right? So it has considerable payload. Or if you're enabling HA for the first time, which again pushes out an AAM agent associated with HA. So anything that involves a payload, these things will probably take much longer. But if you configure your timeout values accurately, we are recommending anywhere around 3 hours, again, depending on the kind of latencies you're talking about here. But 3 hours seems a reasonable enough value to avoid that timeout. Those operations will still fare well. Actually, there's a white paper that's, I think, has been already published that goes into the details of what is the operational time associated with a task if you're running a satellite link versus a 128 kbps link or greater. That will give you more details. Then remote console, right? A favorite topic. Avoid it as much as you can. If you really need to use it, make sure you reduce the size, color depth so that it consumes less bandwidth. An alternative to this would be, use RDP in general as opposed to your remote console. But what you can do is you can RDP into a client that sits at your remote site, and from there you can log in using your vSphere client and use your remote console. So that is kind of better of the two, worlds. Okay, at this point, I'm going to transition over to Praveen, who's going to talk about the ops management piece of this.
Hopefully you can hear me. Okay, thanks Ashwin. So I'm going to spend some time talking about running day-to-day operations with vCenter. Now that you have everything set up, what are some of the things that you can do to make sure everything is running fine, and what you can do to troubleshoot issues when you find them? Let's just dive right into it. First, I'd like to spend some time talking about the architecture. This is important not just to know how things are laid out, But when you're looking at troubleshooting data, it's important to understand the mappings between each of these areas because each of these touch points represents something that you need to look at. The first thing is the core of VC is a service called VPXD. The job of this service is to accept client connections, like requests, and then send it to the appropriate ESX host to process them. And then you also have the service Tomcat that provides supporting services to vCenter. This is something that Ashwin covered a little bit, which I'll go into a little bit more detail in the next slide. But it's an essential app server that provides critical services to VC for it to function and all the supporting services around it. Then you also have a database, and Ashwin talked a little bit about the database, where we store not only information about the inventory, we also collect stats and events. And we persist that over a historical period. And again, depending on the number of stats collection levels, the mileage varies. On the ESX host side, we have a bunch of services or agents running inside that perform very specific tasks. The first one I'd like to call out is something called as a hostd. Now, what this does is basically a interface between ESX and VM-related functionality. So if you, let's say you want to power on a virtual machine, you essentially tell hostd to go power on a VM, and then we talk to an internal layer called Foundry that actually does the actual power on. There's also a module called VPXA, and the job of VPXA essentially is to execute commands on VPXD's behalf. So the first time when the ESX host connects, the VC connects the first time to the ESX host, it first talks to hostd, but then on VPXA takes over. And VPXA also does some takes upon additional responsibility in certain operations like cloning, while hostd does things like power on, or even keeps track of tasks. You can consider VPXA as some kind of a high throughput conduit between VPXD and VPXA. And then beyond all of this, there's obviously some kind of communication still going on between VPXD and the ESX host. Ashwin touched a little bit on this. The first thing is called a host sync. So whenever you have any changes on the ESX host side, it queues it up and says, hey, Mr. VC, I have something to send to you, and it sends it out there. And then on the VC side, it can also go talk to the ESX host when there are changes relevant to the ESX host. So whenever you make changes to the resource pool, for example, those are things that actually have to go to the ESX host. So that sends it down. Now that you have an understanding of this, let's look at some of the things that you can do to monitor things whether they're healthy or not. So the Tomcat web server actually hosts a bunch of critical services, and some of them are listed here. Another service that actually it hosts is actually the service that helps you monitor what's going on with each of these services. It's called the vCenter service status screen, which you can access from the home page on your VI client. So when you click on that button, you get a summary of all the critical services that vCenter has in a collapsed and expanded view. And each of these, like red, green, yellow, represents some internal thresholds that our developers have put together to indicate problems when they occur. So it's a very useful screen to look at. The first one is the vCenter management web services. This actually represents the Tomcat app container. The second one is something called as a query service, and the job of the query service is to accept client requests like search queries, for example, and then even a link mode setup actually distributed across the other vCenter servers in the environment. The third one represents vCenter database. This actually monitors the status of database rollup jobs. Ashwin covered a little bit on that. The vCenter database actually has 3 stats rollup jobs, past day to past week to past month, and then past month to past year. So if any of these 3 rollup jobs fail or there's some problem, you actually get a report on that here. And then finally, you have the LDAP health monitor. This represents the Microsoft Atom service that we have for enabling link mode setups in the environment. So if you find any problems here, you actually can look at the screen here, or I think in vCenter 4.1, we actually have tied it into the alarms functionality. So anytime you have any status changes here, you get notified when something bad happens. The second thing you could actually do, especially when you're running VC in a VM, is to keep track of the performance charts page. Now, starting in VC 4.0, we have a overview performance charts module that provides side-by-side summary views of the key metrics in the environment. And depending on what collection level you have set, the amount of data that you see increases or decreases. It's a good page to look at because you get high-level summaries and you also get like top 10 views of what's going on. The point here is that if you're running VC in a VM, you want to monitor the other virtual machines that are running alongside it, right? Because it can be positively or negatively impacting the performance of VC itself. So when you say VC is slow, maybe this is a good place to look at. There are some common VM troubleshooting tips that you can look at. First one is, I'm sure you guys are familiar with it, the percentage ready time metric, which indicates CPU contention. Anything beyond 20% is a cause of concern. If you have high ballooning and swapping, it's a good indication that the host is running out of memory. You might want to allocate some more memory. Or you can do simple things like add the vCenter VM into a DRS cluster and let the DRS algorithm automatically load balance things. Or you can even add another host to the DRS cluster to balance out the load. Certain things you can look at. I'm not going to go over all of these troubleshooting tips here, but for additional information, you can pull up a very popular white paper that we have on the communities page. The link is out there. You guys can refer it later on. It's got a lot of in-depth information about each of these metrics, what you can do when you have a troubleshooting problem. I'd like to spend some time looking at log files. So each of these services generates logs. VPXD generates something called as a VPXD.log. And what I've done here is basically given you sort of a zoomed view of a log file excerpt. So when you're having some issues that you want to take a look at, what I suggest that you guys do is just run the same support bundle that you send the support guys. You can collect it all in one place and start looking at the information. The first place I would start looking is the VPXD.log. What I've done is provide an expanded view. So let's take a look at that. First one, you have the timestamp. It's pretty easy to understand. Second one is the thread ID. Now, keep in mind, in an overloaded system, not all the log statements are going to be in sequence. So whenever you're looking at a log file, make sure that you're looking at the thread ID and you're actually tracking it through end to end. The third one indicates the actual log level that you have set. You can tweak the log file settings from the UI by looking at the advanced settings. It can be verbose, it can be trivia, or it can be normal logging. And each of these affects how much information is being displayed. Then you have the task ID, which is the unique ID that's given for every single task that is sent from VC to the ESX host. And then you have something called as the MOID. This is the Manage Object Identifier. This is the sort of the unique key that helps you identify an object in your vSphere inventory. And then finally, the actual task that was run. So now that we have an understanding, let's sort of put this into practice. One thing I'd like to look at, or actually two things I'd like to look at, is task activity and then DB-related information whenever I'm troubleshooting a particular problem with VC. Here are typical steps that you need to take into account when you're running a task. So let's say you power on a VM. The sequence goes something like VC initiates a task begin. It sends the task to the host performs the tasks, and then the host sends back a task completion message. And then you issue a host sync, basically saying, Mr. ESX, do you have anything that I need to be aware of? Send it back to me. And then VC receives the host sync, and then VC persists to the DB, and then the task finishes. Why I've actually listed out all these tasks is because, as you can see, there's a lot of interaction going on between the VC instance, ESX, the DB, and maybe even the client for each of these notifications. So when you're troubleshooting a problem, it's good to have a mental map of these workflow of tasks so that you can logically walk through the log files if you're looking for a particular problem. And when you're having some issues with hosting, it's good to look for any network problems between VC and the DB, or between the ESX host and the VC server. Looking at DB information, something interesting for you guys to know is that starting with vSphere, getting all these names confused, VC 4.0, we actually have added DB profiling information. And what this basically means is that we have added some threshold values beyond which some debug information gets logged to the log file. Okay? The first one talks about statement log time. So essentially, whenever a particular statement is delayed beyond 3,000 milliseconds, you start seeing entries in the log file. And then you have something called the transaction log time. So whenever you have many statements within a single transaction, and if it's exceeding 9,000 milliseconds, it gets logged there. And then we also log anything beyond 200 statements within a single transaction. So, and we also log execution time. So here's an example where you see the execution time elapsed is 3354, and then there's something to look at. Essentially, the key takeaway here is that if you see any of these messages within a minute time interval, it's a good indication that something warrants further investigation. And there could be a performance issue that you want to look at. And now, just a key thing to note, you might see a lot of stats transactions. That's perfectly fine. It's normal for it to take a long time. Some of the other tasks, they're on a different path, so those are the things that you want to look at. So what do you do when you actually have a DB problem, something you want to troubleshoot? The first thing you can do is enable DB tracing. What this allows you to do is look at every single statement that has been executed in the log file. And you can do this by editing the vpxd.cfg file, adding this advanced setting, and restarting the vCenter service. Then you can also look at the DB itself to see whether it's low on system resources. It could be that you haven't allocated enough memory. It could be that the CPU is constantly peaking at 75%, which probably indicates a DB workload issue. Or you can look at the disk I/O and see if you have sparse spikes or if the load is continuous. If the load is continuous, then it could be a DB buffer cache issue. Then finally, you can actually run a profiler, a DB profiler. And what this allows you to do is look at the latency issues, the network communication, when the statement arrives, when it gets executed, and when it sends it back to VC. So there are some tools from Microsoft for Microsoft SQL Server, like MS SQL Profiler. For Oracle and other things, there are similar tools, or you can contact your friendly DBA. And finally, if you still can't figure out what's going on, help is at hand. Our GSS team is there to help. We actually have a special flag. Not many people know about it. It's something called as vCenter profiling. Now, this is separate from the DB profiling I just talked about in the previous slide. This profiling option actually adds additional instrumentation to the log files beyond what we normally collect. And this allows us to get some kind of a blueprint of the customer environment. This could be inventory information. This could be information about the tasks and events that VC executed, as well as some historical data around it. And beyond this, we actually can look at performance and scalability problems that are affecting your vCenter server, especially like latency between client connections between the vCenter server and the VI client, or especially when you have multiple clients connected, or if you have any disconnects or timeouts that, that are interesting in the environment. And the way you invoke this is by these special flags that I mentioned here and given some details around it. That's in summary some of the best practices and tips that you can do to monitor and troubleshoot your environment. Now back to Ashwin for the rest of the talk.
All right, so I noticed we have about just over 8 minutes, and so we're going to leave some room for Q&A. I was surprised that there's a mic on this end, there's a screen on this end, so you don't get both of the worlds. Anyway, final one, protection of your management infrastructure. Very important because, as you've seen, vCenter server has become such a critical piece of your infrastructure, right? And as you go to a private cloud infrastructure and possibly at some point to a public cloud where you don't really need to be concerned about availability, but in terms of a private cloud, protection is something you need to consider, right? And what does it mean by protecting vCenter server, right? So there are different aspects of which you need to define based on what aspects of vCenter management are important to you, right? Do you only care about protecting against OS failures, hardware failures in a local environment, or do you really want to go and protect a vCenter server across a remote site, using DR, right? Or all you're concerned about is it just the application integrity and uptime? I mean, what is it? I mean, so you need to define that yourself. The other things you need to obviously define around protection is if there is an instance of your vCenter service going down, what is your expected RTO around it, right? And is there a single RTO figure, or do you have RTO expectations around different management tasks? Whether it's provisioning, whether it's vMotions, DRS, which of the management tasks you do on a day-to-day basis is the most critical to your environment? So you need to think about some of those things, right? And then when I think about availability for vCenter server, there are two gradients of it. One is the depth of protection, which means protecting all the way from the application, to the OS, to the hardware, physical or virtual, to your underlying storage, your network infrastructure, your site. I mean, those are the units that I look at, and this is something a lot of our other customers also look at, right? So do you need protection across this depth, right? The other thing to consider is, what about the breadth of protection? What I mean by breadth of protection is, there is vCenter server, which is composed of a bunch of services. Then there are other components that it depends on, which is your vCenter database. Then depending on what other tools you use, whether it's Update Manager, whether it's Orchestrator, whether it's View Composer for your VDI environment, or other, third-party tools that integrate with VC. So what is the breadth of protection you really want to cover for your environment? Again, it goes back to that earlier point I made. It's very relative to each of your environments, and you need to first figure out what that scope is, and based on that, we can suggest what the optimal solution is. Right? At the very basic, from a very basic discussion point of view, there are really two ways of doing this. Right? One is what we call is the cold standby method, which is basically saying you have some standby vCenter server lying around somewhere, which has been, which is a backup of your primary VC. Then it's up to you to make sure that you continually take these backups at some point in time. And if, let's say, ever the vCenter server were to fail, you can either restore from that vCenter backup, or you can build a new vCenter server, restore the configuration from it, and you're all good to go. Seems simple enough, right? But obviously, it's involved. There is manual effort involved. So depending on what processes you leverage using this method, it can take anywhere from 4 hours to 8 hours to actually get your vCenter server back up, right? One key thing to remember is regardless of what approach you take, it's critical that you retain your vCenter server IP address. Because if your vCenter server IP address changes, then your ESX hosts need to be notified. So what happens is then basically you need to disconnect, reconnect your ESX host in VC, which means agents being pushed out again or whatnot, right? Because now ESX hosts need to be reconfigured. So something to keep in mind if you choose this method. The other method, which is a warm standby method, clustering, host-based replication, these solutions do this today. Essentially, you have a redundant copy available and running at all times, and there is some method that does the replication of the necessary files or of the data if you're protecting the database as well. Again, the same consideration applies, the vCenter server IP. It should not change. If it has to change, then you may need to do some additional scripting to push out the agents out to the ESX host. The good thing about this is, your RTO is much lower. Again, it varies depending on the solution. It could be as low as 1 hour or maybe even lower. But it's really your choice, which depending on the criticality of vCenter server in your environment. What we recommend is vCenter server Heartbeat, which is basically a very comprehensive availability solution for your entire management infrastructure. And it actually is probably the only availability solution out there today that protects vCenter server at an application level. So you may ask, there is clustering. How is it better than clustering? The fact of the matter is most of the clustering solutions, regardless of whichever you use, whether it's Microsoft clustering, Veritas clustering, or whatever else is there, or for that matter, even host-based replication. If you're using DoubleTake, you're using Commvault, whatever it is, most of them are protecting pretty much at an OS layer, at the hardware layer, and maybe in some cases at a network layer. Yes, there are partner add-ons that enable you to go across site as well, right? But then you're talking about 2 or 3 different solutions here. vCenter Heartbeat essentially delivers on the depth and the breadth of protection that I talked about, which means that it can monitor vCenter server performance in real time. If it anticipates there are certain, so it has a baseline of threshold that it thinks if you go above or beyond that, vCenter server is going to go down at some point in time because of whatever issue. So it will actually alert you of a performance degradation, and it will provide you with the remediation methods to prevent a failure. So it will always make sure that your VC server is up and running all the time. And it's not just about the application. It protects against the application, basically the same depths I talked about. Plus, it also enables remote DR. So you could configure a remote site, and if it monitors, let's say, a performance degradation or a unplanned failure, or for that matter, even if you were to do a vCenter maintenance of the hardware or the OS, you could actually do a switchover either locally or to the remote site, such that the application switches over to whatever is the redundant standby server, and you can do your maintenance. So there is really no downtime associated with it. Again, breadth of protection. Today, it's pretty much protects all the core services that vCenter ships with. It protects update manager, orchestrator, converter, you name it. Everything that ships in the vCenter DVD or that zip file, all of those services are protected. Recently, we also added protection for View Composer. So in short, very comprehensive levels of protection using vCenter server Heartbeat. In summary, running VC in a VM, you get HA as well. But again, depends on what's the level of protection you want to deliver. And again, I'm being told we are out of time, but I want to take questions if they let me.
3 questions. Grab them.
Oh, by the way, there are some references in these slides if you download them for some of the detailed information.
Have a fun rest of the evening.
Hi.